Hi friends, today we are going to see a stress and deflection analysis of 2D stress by using Ansys Workbench. See here, this is the problem of the stress element, that is 2D truss element. See here, one end of that truss is fixed and another end is supported with the help of roller. Then we have to open the Ansys Workbench. We have to click here on Workbench. Then that Workbench toolbar will be open and we'll get one icon of the Workbench. Here we will see the various analysis from which we will select static structural analysis for the analysis of the stress. Here that static structure icon will be open here. Here by default he has taken the engineering data. That engineering data consists of the material values. That material value consists of various material like structural steel, copper alloy, aluminum alloy, concrete. Like that material will be consist of that engineering data. By default he has taken structural steel. Now we'll see we have to create a geometry of that stress. For that purpose we have to click on that geometry icon. Then here the starting design modular a notice will be generated here and design modular will be get open. See here by default he is asking to beneath. Now our stress is in meter, so we'll take meter. See here we will get xy, zx and yz plane, from which I will select xy plane. Look at, then I will draw the line diagram of the stress. That P will indicate the point, starting point. Second element, then third element, then here we get a line which has been we have drawn. We have to draw a structure of stress like this. See here we have to draw a dimensions first, that is h1, this will be h2, this will be h3, now length of the first element is 1 meter here, second element is of 2 meter, third element is of 1 meter, first 1, then that will be 2, that will be 1, then height of that structure will be 1. Now this unit is in meter, so for that purpose I will zoom this sketch. See here, next I will draw here, this line is not joined here. Next structure line is this. here length of this element is 1 meter, so I will give dimensions to that. That will be of 1 and 7 is of 1 meter. Now here we have created a structure as per our requirement. We will zoom it. Now here we have to add, this is the 2D truss, so we have to add the cross section here. For that purpose we have to go concept, cross section, circular, because the size of the structural bar is the circular in cross section. Here radius of this cross section is 0.01 meter, that I will increase to 0.25. Then here I will generate the body. Next we have to go into concept, line form sketches. Now that we have to generate that sketch. Line is generated from that sketch. Then next here body is generated. Now this generated body we have to assign with this cross section, then this beam, this structure will assign the circular cross section. Then generate. Here we'll see the cross section of the truss will be circular. After zooming this we will see. Now we have to go into model. Now this model will be updated here. Then we have to generate mesh. Here see mesh is generated in that structure. Now we have to fix this node. Insert, fix support we have to apply here with the help of this node. Apply. Then next we have to apply roller support here with the help of this. We have to apply displacement here, because in roller support the y direction is restricted and that roller will be moved in x and z direction. So here I will give 0 displacement to the y. Then next I will apply force here as per this diagram. That 10 kilonewton force is applied here. We have to go insert force here, apply. For applying force in negative y direction we have to go here, apply component y minus 10,000 Newton, then it will be converted into 10 kilonewton. Then next force will be apply here, apply vector. Now here all forces and all supports are added. Now I have to take solution. For taking solution I have to see the deformation and stresses which are generated in that structure. Deformation, that total. Then insert beam tool. That beam tool will show me the direct stresses which are generated. I have to solve it. Solution will be generated within some time. It will take a fraction of seconds. After solution, we will see how the results will be. See here, this will show the stresses which will be developed here. Now see the unit is in Pascal. I will convert that into an see here the 5.07 megapascal stress, direct stress will be generated in that structure. I will show deformation. Here deformation 0.2260 mm, that will be the deformation of that diagram. Here see that this animation will show you the deformation. Next, if you want to the stresses, here that will show here. That will show the deformation from original position. It will show maximum stress, where will be the maximum stress. Maximum stress will be here, which is shown by this graph. Minimum stress will be here. That probe will show the stresses which will be in each part. Each stress member. So we have successfully solved this problem of the stress. Thank you.